Hi, I'm Bill McKeegan. I'm the president of Tandagostino Master Audio Systems. We are very excited today. We have our wonderful distributor, Roico, in from South Korea, as well as our leading dealer, and pretty much the leading dealer in Korea, AVPLAZA. We've been doing business with them for a very long time, and it's wonderful for them to finally be here in our facility to show off everything that we do, how we do it, what each process and every step of the way goes into our final product. So we are very thankful for the Korean fans we have. The Korean customers have been wonderful to us over all the years that the company has been around. And again, we're excited to have AVPLAZA and Roico here for a nice little tour, visit, and some training. All right, Rob.
How you doing, guys?
All right.
Two things we do. One is we inspect our boards before we populate them. And what we're looking for is just consistency of the manufacturing. Get kind of under magnification here. So when we get a batch of boards, we like to look at them really close and kind of spot check some of the features on the board. What we're looking for is a nice clean edge around the pads. No distortion or any leakage of any of the copper going, making connections we don't want. I'll just let, right about in this area, that board is a fatal mistake.
안 좋은 거 하나라고 하는데요.
Now when you see it here, it becomes really obvious. Right there. But once we find something like that, now we know, okay, this whole batch needs to be inspected really closely. If we find any more like that, we won't check them all. We'll just reject them all. And the other process we do over here is once the boards are completed, they come off the wave solder. Again, we're going to put them under the same magnification, and we're going to look for the quality of how did the solder actually go onto the board. We don't want to see any pinholes or any kind of distortion in the solder would indicate maybe a problem with the wave soldering process. We spot check a couple of boards. Everything looks really, really good. We look at it up close. Everything's good. This board will be ready to go for a final inspection and get tested. What we do is we hand build like this process here and populate the board. We'll put it through the wave machine. But certain parts, like these relays and some of the larger capacitors, they can't go through the wave. So phase one, we will populate all the small parts. We'll wave solder it. It'll come off the wave. We'll inspect the solder connections. Everything looks good. It will go back to the person that built the first stage, and they will finish putting on these parts and putting them on by hand. And then it'll go through, after that, yet another cleaning and inspection process to make sure that the hand soldering is up to the same integrity that the wave solder was done to.
This is our wave solder machine. Does anyone here know why it's called a wave solder? We are actually going to generate a waterfall or a static wave of molten solder that the circuit boards are going to pass over. And so I'll kind of walk you through the machine, but real quick, I'll go ahead and turn that on so you can see why it actually is a wave solder process. The first step when the board goes in, it goes through what's called the flux applicator. And kind of hard to see it, but underneath the board is a spray gun, similar like what you would paint a car with. Really high-end titanium spray nozzles. They are on a programmable conveyor that go back and forth, and so as the board goes past that, it's going to spray flux on the board, which, because this solder is just pure solder, it doesn't stick or flow very well. So we apply flux to the circuit board first, so that when it gets to the vat, the solder process will take place. Once it passes through here, the next step is the preheater. And the idea of this is we don't want a room temperature circuit board to come in contact with 250 degrees Celsius solder. The parts won't solder well and it could damage the circuit board. So we're very slowly, as the board passes through this oven, bringing the temperature of the circuit board up. We want usually about 100 degrees cooler than what the solder is. So right now our solder pot's about 250 degrees. we're going to heat the board to about 150 degrees. And the other process that does is the heating is what activates the flux and actually gets it into its chemical state where it's ready to work on a board. So that's about 500 pounds of molten solder in that vat right there. And this is a calibrated wave where we're measuring how much of the solder is flowing forward versus how much is flowing backwards. If too much flows forwards, it goes right past the part and doesn't solder it. If too much solder is flowing in this direction, it follows the board and will cause bridging. So we're looking for the solder to be just breaking off that wave in a precise amount of kind of 50-50. That lets us know that it's going to be in contact with the board for the correct amount of time.
All preamplifiers have three jobs: an input stage, a volume control, and an output stage. They all have those jobs. Now there's lots of ways to do it. You can put all those jobs on one board. Both the left channel and right channel, all one board keeps, if you want something small, you'd have to do that. You might make your volume control just a little integrated circuit, an op amp, a little chip, right? It's a way to kind of keep costs down and make something simplistic. The way we start out is with a progression preamplifier, our first step, which is actually behind me here. And now the left and right channels, those three jobs, are put on two separate boards. This isn't fully dressed yet, but the left channel and the right channel, but the input, the volume, well, it's input, volume, and output are all on that one board. Then when you go up to momentum, both the preamplifier and the integrated amp, we take it another step. Those three jobs are now broken out into 6 boards. So we go from very generic out in the world of one board to the beginning of ours, 2 boards left and right. Now we go to the next level of sophistication where it's 6 boards. So it's input, volume, output, input, volume, output. All right, so it allows us every step you get more room, you can make a more sophisticated circuit every step of the way for each of those jobs. Right? I don't have a relentless preamp here, you'll see it tonight at Dan's, but now we take that up yet another level. Right now it's its own chassis. The left channel has its own chassis with input, volume, output, another chassis with input, volume, output. So from, again, 1 board, 2 boards, 6 boards, 2 complete chassis with 6 boards. That's and every step of the way, you can't get more sophisticated without getting bigger. There's really no way to get better sound without getting bigger, because you can do so much more with the circuit paths as you get larger. So that's the preamp stage right here. Obviously, when you have a preamp to an amp, and there's wonderful benefits of that, and obviously you've heard plenty of that, but you never know what preamp what amp a preamp is going to be connected to. So you have to set up your outputs and your inputs for the world to use, right? And that's your input impedances and output impedances, a whole bunch of technical stuff. But in an integrated, your preamp knows exactly what amplifier it's getting connected to, because it's obviously right here in the box, right? And that allows for an amazing kind of change to that output side of the preamp when it knows exactly what the input side of the amp is. Virtually they meld, and the output of the preamp is integrated, no pun intended, integrated into the input stage of the power amp. It makes for an unbelievable partnering of those 2 circuits. All right, so you have those 2. Obviously the input stage, or the input connectors, I should say, if you were to add the optional phono, that would drop in here. If you add the optional digital, that's here. So it's an all discrete digital analog output stage. Those are that's the output stage there, the streaming engine, right? So your Tidal and Qobuz and all that lives on the top board, right? And then that's also integrated into the network side of it. So the network with the streaming board, so it's a 3-board operation here, and that is the optional DSM, or the digital streaming module, will drop in that. What's nice is that you can add that at any time, right? So if somebody starts, it obviously has Wi-Fi as well as the RJ45, the Ethernet connectivity, coax, optical. This is the same as what's going to be in the new preamplifier in the Momentum series. And then on the Relentless, this takes another step up. The streaming is the same core, so your progression integrated preamp the MXV integrated, the new Momentum preamp, and the Relentless all have the same operation, same app, same title connectivity. All that stuff is all uniform or universal, and it's the output, the DAC and the output stage that starts to climb up the performance ladder as you go up in the channels or in the chain. So you've had the Momentum HD preamplifier, right? And the audio chassis gets connected to the power supply with a cable. Whereas on here, this guy has a foot system. So he's going to end up coming through here like this. And then the power supply, that's going to sit and lock right in to the power supply. So these are 30 amp, individual 30 amp connections. So the highest current we can possibly get from the power supply up to the audio chassis. We're not using 30 amps. It's not quite that demanding, the audio chassis, but the idea is having the cleanest, most direct connection from the cable or the power supply up to the audio chassis, and a cable is not that. So that started in the Relentless preamplifier. It's here in the MXV integrated. It'll also be in the new preamplifier as well. A lot of the stuff we do with multiple chassis will have that as its connection system. To the Momentum, the MXV integrated, the power supply that we were sort of hinting at with the audio chassis. So this is built upside down. It's built upside down so that we can build or use one solid block of aluminum. As you can tell, there's no side here, there's no front or back. It's one solid block, and we hog out the internal section, and then this ends up being the bottom. Is this all mounted? Yeah. Oh, that's gonna fall out. So that's how that will end up looking, and there's the foot that I was mentioning earlier. So that there's no visible fasteners. It's as clean and as elegant as it possibly can be. And that carries on throughout the Momentum series. A lot of them get, so the transformer will be next. There's actually 3 transformers. The main power transformer, then there's an analog transformer for the rest of the analog circuitry, and then a digital transformer, not only for the DAC, but also for the buttons, the volume control, the remote, all that digital circuitry is driven or powered by one separate power supply or transformer, literally. You know, obviously these are the output rails. Give a lift to that, Roy, if you want to. Feel. Copper is super dense, and that's what makes it heavy, of course, the density, but also makes it so good as a heat sink, is that solidity to it. This chassis has changed over the years to take care of the upgrade path and some of the performance enhancement. This used to be a much shallower or thinner transformer, so we've been able to, in the same footprint, increase it by cutting a extra pocket in this faceplate, and right in this front we insert the second transformer. Is tucked inside there, which you can see from the back side, but it's the same idea. Big power supply, lots of output capacitance or power supply capacitance. The relays, the same structure, and then the heat sinks. Now this also is, Jesus Christ, is one solid block of aluminum, right? We're building this upside down as well, right? And then obviously we have to mount the heat sinks. There is a separate rear panel, and then the top, which of course becomes the bottom when you flip it over. Again, the most elegant possibility or elegant presentation we can make without the screws. All right, let me show you something that's fun. I don't know if that's obvious or not to you guys, but we build all of our own meters. All this is done by hand as well. This is an M400 MXV meter. You can tell by the MXV, the latest generation, but they're all done that way. The volume controls, we've taken great care in the design of the volume control in the Momentum preamp, which is same as in the MXV integrated amp. You know, it's that thing that people touch. It's that tactile feel, the one thing they have, and we want it to be the most elegant, kind of rich feeling when they open it up or you know, adjust the volume. We do volume controls differently than everybody else. Not only the mechanical side of it, but the electrical side, even more importantly. A lot of volume controls, the circuitry leaves a resistor in parallel all the time, and it sucks the life out of the sound. The dynamics get killed. what we do, and you hear it with the volume control. It's why I mention this. You notice ever when you adjust the volume on the HD that there's a slight click, right? Those are relays, right? Or individual relays that are only inserting the resistor in line appropriate for the volume that you've set, and only that, so that we get the cleanest, tightest pathway from the input to the output, right? Those two jobs, this sits in the middle. And no one does it like that. It's usually one little chip that gets volume, and it, again, doesn't have that richness and body that we achieve. The mechanical side is way beyond what anyone else does. So we especially noticed during COVID times, trucking became a real challenge, shipping. And you can tell as we move things around the factory, they're on carts, there's foam, everything is treated very, very beautifully and nicely. And then a trucker gets it and it's not so much. So we wanted to try to, especially during COVID, we saw some shipping things that we didn't like in terms of failure and that stuff. So we wanted to try to simulate that step when it leaves our building as to what's happening to it, and maybe if we simulated it, we could adjust for it at the company. So we custom made had a table made for us, custom made stainless steel table. It's two separate parts, the main base and then the shaking table itself. A big motor, which I think this is our third motor. We've burned through two of them already. And every unit goes in either in this box, or we strap it if it's a larger unit, depends on what we're doing. So there's a progression integrated in right now, or in there right now, so give it a little whack. So we'll let that go 15 or so minutes for every unit. And if there's something loose or cable hasn't been put in properly, or a header or board hasn't been inserted into a header properly, we're going to catch it here. So everything gets there, and then we do our final test from there, which we'll go to next.
All the results go to the computer test, and then so we are looking gain, distortion, noise level, and maximum power out. We are able to see all the steps on the computer. So if there is a very little issue inside the amplifiers, the computer catching easily. So, and we are using the AP audio precision test analyzer. Probably you are using also in your Roico store. And then so you have this one I seen on the videos. Right now, I am going to show you as a manual. I am not going to run all the tests. I am going to show you how we are looking the gain option. So when you look the gain option, we are looking both channel, the stereo or monos are even numbers, like they are very close to each other because those are analog system. Like for example, one channel is 23.9 and the one is almost 23.9, very close to each other, very little difference, like a 0.02 difference between the channels as a tolerance. And then so we are able to see the noise level, we are able to see acoustic response, we are able to see the maximum power out. I am going to show you in here. So right now I am going to show you how much this amplifier S350 350 watts amplifier makes in the real power. I am going to show you. So I am going to run the test right now, and then all the test results comes on my screen, and then I am going to save these results in my system. And then so if in the future, and it allows me, to track what kind of system, what kind of test results we send the customers. Right now, this amplifier actually supposed to make 350 watts, but right now in the real power, it makes 385 watts, like a 35 watts above the we specified on the manual. So actually, this amplifier, it makes more power, the 35 watts more power in the reality. So we are seeing the whole test results here. Like if there is any little difference inside the amplifier, we are able to catch on the computer as a final test. After final test, the amplifier goes to the listening test, and we are listening through the speakers, and also we are looking if there is any issue or difference between the channels, or like inside the amplifier we are able to catch through the speakers, like last test.
Will you go ahead to the urban town and the highly red on the night? Dirt under my shoe from the old light hall, right under you, grinning in the dark.
구독자 여러분들, 드디어 9박 10일 동안의 미국 투어가 끝났습니다. 매킨토시, 웨스턴일렉트릭, 그리고 단다고스티노까지 정말 다양한 제품들을 이제 보게 되었는데요. 어떻게 이렇게 제품들이 만들어지고 탄생됐는지, 그리고 이런 제품들이 만들어지기까지 얼마나 많은 노력들이 있었는지 그거를 다시 한번 이해하게 되었습니다. 저희 로이코가 올해 35주년입니다. 저희가 취급하는 브랜드가 요 세 브랜드 말고도 또 다양하게 있지만 그 외의 브랜드들을 앞으로 또 좋은 기회가 있다면은 AV플라자와 함께 같이 여러분들께 보여줄 수 있는 그런 기회가 있으면은 좋을 것 같습니다. 네, 앞으로 많은 제품들이 또 출시 예정인데요. 여러분들의 많은 기대 부탁드립니다. 저는 그리고 로이코의 정로이였습니다. 감사합니다.